Now in this question, part B, we're being asked to consider how we can work out three isomers with the formula C3H6O2. And there's different conditions they can make. One has to have neither geometrical optical isomers, so there can be compound Y has geometrical isomers only, so it obviously needs a double bond. And compound Z has optical isomers only. So there's some structures which should come to mind immediately, and then from there, through a process of just playing around with them, you should be able to work it out. Now, remember we've got the formula C3H6O2. Now if we look at this one here, this is just a straightforward carboxylic acid. Then we've got an ester, realizing that we can switch this around. So for instance, on this side we've got the carboxylic acid would have had 2 carbons, and we could make it one with 1 carbon and simply have the other, another carbon on this side, the alcohol side of the ester. We could also have a double bond in there, and to make 2 O's we could just have 2 alcohols in there, some kind of diol of some kind. And then we could also have an aldehyde, because an aldehyde with a single bond, double bond O there, a carbonyl, and an OH there, that would also be a possibility. So realizing that these are possibilities, we just have to make sure that condition is met. Now obviously when we're looking at the acid, that can't be a geometrical isomer, and if you can never have a asymmetrical chiral carbon on anything that's got a double bond for a start, and so it can't be that. And it has neither geometrical nor optical isomers. So this one has neither geometrical nor optical isomers, so this could be a possibility for X. There may be other possibilities as well. Now if we look at the second one, this alkene, if we were to move the OH around, we could probably get something which could have optical isomers. So let's have a look at that in a second. And if we look at this compound here, the aldehyde, this has no, there can't be a chiral carbon here, because that would be an optical isomer there. So we'd have one group there, one group there, one group there, one group there, so that would be that. So that would be a possibility of a optical isomer, but not a geometrical isomer. So that could be a possibility for Z. Now if the OH was moved along one, what would that happen then? Let's consider that. Now if we have the OH there, do we have, obviously there's no double bond, so there's no geometrical isomer. We can't have an optical isomer, so this would be here a possibility of an X. Alright, so there's 2 possibilities, neither geometrical nor optical isomers there. Okay, so if we carry on still more. So basically what I'm doing is I've recognized that we can have a carboxylic acid. There's only one carboxylic acid, so after that, recognizing that's X, we don't have to do any more. There's 2 possible esters, one like this and a second one where we have the alcohol and acid switched. So we can decide which of these X, Y and Z is going to be. And I've effectively done the same with this, where we've had the aldehyde and we've had the OH here and we've had the OH here, and identified those 2 possible isomers there. We've had an X and a Z in this case. I shouldn't use that. We've had a X and a Z with here, and an X with the OH was there. Okay. Now, in this case, this is obviously not a geometrical isomer. It's not a optical isomer, so this is another case of an X. So there seem to be lots of X's. And if we switch this around, so we had it the other way, If we just switch it around, we find that we still just have another X, but I would list them both. Okay, so far we've covered these three possibilities. Now we need to look at this one a bit more. Now this has probably the greatest variety, and if we look at this, we find that for this first one we basically have the alcohol group on the first, well, it depends how you look at it really, on this carbon here anyway. We just move the double bond. Neither of these are geometrical isomers because they've got the two H's here, and the two H's on this side as well. So that means both of these come under the category of X, which is neither geometrical or optical isomers. None of the carbons have four different groups in them. Whereas if we look at Y, where we're shifting one of the OHs next to each other and then far apart, or the 1 and 3, then we have two different groups here, two different groups here, two different, and that means these are both geometrical isomers. Now I drew this one initially, but of course this is exactly the same as this one here. So anyway, so these are four that I'll draw down and label as they are, and that's that question answered. I was going to say I haven't bothered naming these because I thought the more difficult thing was actually working them out, and these dials are just named in a fairly straightforward way. There's three carbons here, and so there would be, this would be propene 1,1 dial, and this would be propene 3,3 dial, for instance, here, and this one here would be propene 1,2 dial, and you're getting the picture here, and this one here would be propene 1,3 dial down here. So they're fairly straightforward. Anyway, that is that question. I'm assuming you can name esters and also aldehydes as well, as that's more NCA kind of level, but just figuring them out, I decided to go through that process.